on the shaft. Sleeve is used as a bearing. You want to get by? Up, it needs cleaned off. Where it's at, right here. bottom roller isn't moving, it might be holding it back.
there's so much buildup on there that they don't move. So that offers some resistance. One turn anyway. They look like they're free enough to turn. Since this isn't going in, the force is up like this, they don't move. On the other side is going to run into that main beam down there. It'll have to be cut off. Here where that opening is in the door.
not really changing everything with that sun over there.
That's weird.
LMPT team Haley's Comets. We wish to welcome everyone here today for our presentation. My name is Dennis Cagney, co-leader. I'd like to introduce the members of my team. The members are Tony Haley, co-leader, Ken Kopis, Bob Thomas, Bill McDermott, Bill Brenner, Al Corey, Bill Smith, Dennis Rabowski, Roy Sample. Now here's Tony Haley.
The group's first meeting after training was held on June 20th, 1986. The coke and coal spillage on the batteries was the focus of the group's attention. The magnitude and complex nature of this problem soon became apparent, so we decided to work on it as several smaller projects. Our first problem to be solved will be coal spillage below the bench level. Coal from the leveling process is constantly being spilled in various areas on the battery. The team has found piles of coal in heaters' alleys, entrance doorways to the ovens, against the alley walls at track level, on the benches, and in coal spillage pits. All of this coal represents a large capital investment that is being wasted. In addition, it creates safety and health problems, along with being very unsightly. The group feels that if it could find a solution, it would be a major contribution to the corporation. The reasons we chose this problem are cost savings, safety, and very visible. These conditions can be found on a battery at all times. I would like to introduce to you Bill Brenner.
Our group visited the pusher side Coke Oven area with the individual investigation is showing several reasons for the spillage. Number one, pusher coal boxes hold more coal than a skip hoist. Some operators dump the box with a skip hoist up. Failure of the skip hoist to empty completely, especially in wet weather, are all causes for the bottom of the pit to fill with too much coal. Cause the bucket not to go low enough to accept the coal from the pusher, and mechanical breakdowns of the skip hoist. Number two, some operators fail to use the skip hoist or they forget to close the box. This results in dumping along the pusher tracks and in the alleys. Number three, failure of the pusher smoke box to extend to the chuck door. This lets drag back coal to fall to the bench instead of being collected in the coal box. If the operator fails to dump the coal box and the coal level gets high enough, it prevents chutes from going up. Also, silicon spray on the chute jams joints between smoke box and coal chute, preventing smoke box from extending. Also, lack of grease and or frozen pulleys on various portions of the smoke box sections. As number three is a more extensive problem, it will be treated separately as a future solution. I would like to now introduce Bob Thomas on proposed solutions.
We feel that we have arrived at a reasonable solution to number 1 through number 4 of the problem as stated in the pattern section. We feel that it can be accomplished at a reasonable cost. It is therefore our group's proposal that the coal boxes on the pusher be turned around so that they face 2nd Avenue, so that they can be dumped between the pusher traction rails. This can be accomplished on the wheel-put machine by cutting off the bolted lower section, rotating it 180 degrees, welding the bottom section back into place. The copper pusher is a slightly larger problem. The dump lever linkage would have to be modified slightly so that the gate would operate. Once the pusher modification is completed, dump zones would be established in areas that are normally free of debris. One dump area for each unit, from which the coal would be picked up with a front-end loader, loaded into a truck, and returned to the reclaimed coal area at the coal handling department. The proposed dump area would be the downriver end of P1 at our or beyond the door area room, the area upriver of the doorway at P3, an oven office, the area upriver of P4, repair room. I would now like to have Bill McDermott give you the benefits of the proposed solution.
The benefits from this project would be: 1. Coal could be recovered at its exact cost minus a small cost to return to the coal handling. 2. When disposed of as pusher track refuse, we would no longer be charged transportation or disposal fees. 3. Coal spillage pits would never again need to be cleaned, saving cost of LTV labor and sucker trucks. 4. It would be impossible to dump the coal box in the doorways, alleyways, or along the pusher tracks and rails, thereby saving the labor to clean up these areas. Number 5. The skip hoist would never have to be maintained and could be done away with, saving maintenance man-hours, replacement part costs. 6. The hoist areas could be converted to debris chutes, replacing the wooden ones at the end of the batteries, saving their maintenance cost and eliminating the need to wheel debris to the end of the batteries. Even if the dump areas are not established or used by anyone or everyone, numbers 3 through 6 can still be realized. Here's Dennis Habowski to explain the data we had collected.
Our team determined the operations that should be observed: the leveling bar, the chuck door, the skip hoist, and all operators. As a team, we observed the normal operations. We also added weights to number 2 pusher and watched the entire operation on all batteries. Dennis Cagney videotaped the pushing procedure on all batteries. I would now like to turn it over to Al Corey. He will speak on estimated maintenance and cost repair for 1986.
We have some estimated maintenance and repair costs for 1986, plus potential savings for maintenance and material. The skip hoist repair, we had 2 millwrights at $21 an hour for 30 days. This came to $10,000. Skip hoist repair again, we had 3 riggers at 16 days at $21 an hour. This came to $8,100. We had the vacuum truck for cleaning the tracks for 12 days at $65 an hour, plus a laborer for those 12 days at $16.47 an hour. That came to $7,400. Then we had the cleaning the pusher tracks. We had laborers for 104 days at $16.47 an hour. That came to $13,700. The estimated maintenance and repair cost for 1986 is $39,200. We can realize a potential savings from this maintenance and material at $57,000 a year. Now I would like to present the potential savings from recovering coal based on the following assumptions. Contaminated breeze, that is contaminated with coal, at $24 a ton selling price. Composite coal blend cost, $43 a ton. Refuse disposal cost, $100 a truck load plus approximately $75 to ship. Percentage of coal and cleanup cook, approximately 20%. The approximate contaminated breeze generated per quarter, 400 tons. The approximate refuse generated per quarter, 300 tons. We can realize our potential savings as follows. From contaminated breeze, 400 tons contaminated breeze times 20% coal per ton contaminated breeze times $43 per ton equals $1,520. From the refuse, 300 tons of refuse times 20% coal per ton of refuse times $43 per ton of coal equals $2,580. From disposal savings, 300 tons of refuse times 20% coal per ton of refuse divided by 20 tons per truckload times $175 per truckload of disposal and shipping equals $525. The total estimated potential savings per quarter, A plus B plus C equals $1,520 plus $2,580 plus $525 equals $4,625. Per year, it's $18,500. All these figures above were based on estimates from Mr. George Rankin. This concludes our presentation. We wish to thank you for coming, and we will answer any questions at this time.